Okay, good afternoon. Welcome to online classes again. We were discussing states of matter, so I'll continue with that only. Okay. And you can WhatsApp me on this number 9463767446. This is my WhatsApp number. You can use this number for any kind of interaction. Okay. Now, last time we had discussed about the states of matter, how the state of matter exists in different states. Okay, what are the conditions which is required for changing the states of matter? Okay, and we had discussed that externally there are two factors, that is your temperature and pressure. Okay, which will decide the state of matter in under any given condition. Okay, if you have, let's say, if you change the temperature or if you change the pressure, how the state change will take place. And another was your internal condition. Okay, that is your thermal energy and the intermolecular forces. Okay, so if the temperature and pressure is fixed, okay, why is it that different substances exist in different states? Okay, that depends upon the balance of these two. That is your intermolecular force and the thermal energy. Intermolecular force bring the molecules together. Okay, and the thermal energy, it takes the molecule apart from one another. Okay, so we have this is all this and all the basic related to the mole concept. Fine. Now, basic related to the states of matter. Now, we had come across the terms where we were discussing about the pure substances and impure substances. Okay, the pure substances and impure substances. Now, what are pure substances? In chemical term or in chemistry, we have got only two substances which are pure substances. One is your element, okay, and another is your compounds. These two are the pure substances. Okay, rest all the substances they are impure substances, or we call it as mixtures. We call it as mixtures. Okay. Just message me if everything is fine. Audio, video, board is properly visible. If you can WhatsApp me on this number quickly, do it. Hurry up and mark your attendance also. Quickly do it on this number 9463 767 446. Fine. And please do let me know if everything is fine. I'll just wait for a while so that I can get the message. I'm not very sure if everything's fine. Is it that I'm not getting the message, or you've not sent it yet? Please hurry up, send me a message quickly. Okay, anyway, I'll continue. I think the signal might be lost or it might be weak. Now, mixtures. Basically, when we talk about the impure substances, they are the mixtures. Okay, the mixtures, if you divide the types of mixtures, then you get two types of mixtures. Okay, one is your homogeneous mixture, and another is your heterogeneous mixture. You've got two types of mixture, one is your homogeneous mixture and heterogeneous mixture. Fine. These are the two types of mixtures: homogeneous mixture and heterogeneous mixture. What is homogeneous mixture? Let us suppose you put salt in water. Okay, you put salt in water. You will see that the salt get uniformly distributed in water. Okay, you cannot differentiate. Okay, one portion of the salt solution from another portion. There's no differentiation in terms of everything, in terms of visibility, the physical appearance, or in terms of taste, okay, or in terms of the composition. Okay, it is uniform throughout. The same composition is throughout the solution. Okay, if it is so, then we say that it is a homogeneous mixture. Okay, so basically, in the homogeneous mixture, we have the uniformity of composition throughout. Okay, there is uniformity of the composition throughout. That means the same composition is throughout the mixture. Fine. Are you clear? This is done. Now, what is the other type of mixture or impure substance? In this case, we have got a heterogeneous mixture. Now, let us suppose you have a container. Okay, you have water here. Okay, and to it you add some, let's say, chalk powder. Okay, or maybe dust or sand. Okay, let's say, or dust. Okay, the mud. Now, do you feel any kind of difference between this one and this one? Will you be able to see any kind of difference in these two? Of course, yes. Okay. In this case, you will see that the distribution of chalk is not same throughout the liquid. Okay. There might be the concentration of chalk powder somewhere in more amount, somewhere in lesser amount, or you will see that some of the chalk, if you allow it to stand for some time, they will start settling down at the bottom, or even the dust or muddy water. Okay, if you allow it to stand for some time, then you will see that they will start to settle down at the bottom. Okay, and the solution will turn turbid. Okay, it will not be clear. The mixture will not be clear. So in this case, if you take two parts of the solution, let's say, or mixture, if you take two parts of the mixture, let's say suppose here you are taking two parts of the mixture, then the composition of this part will not be same as this part. They will have entirely different composition. Okay, here and here. If this is so, then we say that the composition is not uniform throughout. Okay. If the composition is not uniform throughout, then this type of mixture we call it as the heterogeneous mixture. Fine. Now, let me discuss some other properties of these two. Let us suppose. Let us suppose here. I'll just do this now. Okay. I'll just write some points about these. If you allow the salt solution to stand for some time, okay, let's say 1 day, 2 days, okay, or even if you extend the timing, okay, let's say you keep it for 1 week, of course not in the sun, okay, not allowing it to evaporate completely, okay. If you allow it to stand for some time, ठीक है ना, एक दो दिन के लिए रख लिया, ठीक है ना, ऐसे नहीं कि धूप में रख दिया तो उसका evaporation भी हो रहा है, ठीक है ना, not in that way. So what you will find? Will you see that the salt settling down at the bottom? Will it be that the salt will start settling down at the bottom? Yes or no? Okay, chalo, fine. I am getting messages now. Chalo, fine. Okay. Now we can interact. Okay. In fact, I was just not very sure whether I'm able to connect to you or not. Now I can. I'm getting the messages. Okay. So the board is visible. Yes, sir. Everything is clear. Okay, fine. So wait. Just let me see if anything is. Just you send me your name. the marking of attendance. That means you are present, you have attended the class, okay, and that doesn't mean that you will not participate in the class interaction. You'll have to participate in the class interaction. Whatever we discuss, you'll have to give me reply, okay. Then it will represent that you are present, okay. Now, what I asked was, will it be that the salt will settle down after some time? No, it will not settle down. Okay, you will see that the salt remain in its dissolved state. So that means, is it stable or unstable? Is the salt solution stable or unstable? Stable in the sense it remains dissolved in the water, and unstable means it will start settling down at the bottom. The salt will start settling down at the bottom. Of course, it will not settle down at the bottom, is it? So here, what you will see is the salt is stable. The salt solution is stable. That means homogeneous mixture are quite stable. Okay, once they are formed, they remain as such for quite a long time. Fine. Now, you take a strainer or filter paper. Okay. Try to separate the salt from the solution. Okay, through the filter paper. Will it be possible to separate it in that way? Is it possible to separate the salt solution from the mixture in that way? Yes or no? I don't think it will be possible, isn't it? You won't be able to separate salt from the solution by passing it through the filter paper. Okay, so that means they cannot be filtered. They cannot be filtered. Okay. Next, the previous day I must have given you example of, let us suppose, if you pass light through it, okay, if you pass light through the solution, salt solution, will you be able to see the path of the light? Okay, the path of the light is not visible. Okay, so these are some of the conditions for forming the homogeneous mixture. Okay, and this type of solutions or this type of mixture which has got uniform composition, okay, they are called the true solution, or you may simply call it as solution. In this case, the particles, okay, of I have used the term here solute. Okay, I have used the term here solute. Maybe you are not aware of this term solute. Okay, basically there are two components which makes up the solution. Okay, or the mixture. One is your solute and another is your solvent. Okay, if you have got solid and liquid, forming of the mixture, okay, then solid is considered as solute, and this is called as solvent. Okay, the solid is called as solute, and the liquid is called the solvent. Right? These two components mixed together, they will form the mixture or the solution. Okay, so in this solution, there are two parts. One is solid and another is solvent. If it is between solid and liquid, then the one which is solid is solute, and the one which is liquid is solvent. Fine. However, if you have got both the substances as liquid, then the one which has got higher concentration, the one which has got higher amount, that will be your solvent, and the one which has got lesser amount will be your solute. Fine. That is the case when you have got liquid mixing with liquid, okay, solid mixing with solid. In that case, you would have to see which one has the higher amount. Okay. So I hope this is clear. Although we'll be discussing about this later on, okay, and the exact definition is not in this way. Okay, is it clear? True solution. Okay. Next one is the heterogeneous mixture. Okay. In the case of heterogeneous mixture, first of all, we have discussed that the composition is not uniform throughout. Okay. The composition is not uniform throughout. Okay. The composition is not uniform. Second, if you allow the turbid water, okay, or muddy water to stand for some time, what happens? What do you observe after some time? Okay, maybe 1 hour, 2 hour, 3 hours, okay, maybe a day later on. What will you observe? What will be your observation? Okay, please give me your replies, send me your replies on this number. I wait for your answers. Okay, please send me replies on this number only. This number only. Now, what will you observe? What will happen to, let's say, chalk dissolved in water, or let's say the dust dissolved in water, or muddy water if you have? You will see that after some time, the salt or the chalk powder will start settling down at the bottom. Okay, that means the mixture which you had formed, was it stable or is it stable? It is not stable. Okay, so the mixture which is formed here, in the case of hydrogen mixture, it is not stable. Okay, now can you filter it? If you pass the mixture through filter paper, okay, or let's say strainer, or maybe a fine cloth, if you put, then you will notice that yes, they can be filtered. Okay, so can be filtered. Can you see the particles of the mixture here? Can you see the particles of the mixture here? Yes or no? The particles will be visible, is it? So in this case, the particles, of course, of the solute are visible. Okay, the particles of the solute are visible, and if you pass light through it, then the path of the light will become visible. Okay, path of light is visible, and this effect is called the Tyndall effect. Path of light visible, okay, when we pass light through the solution, and if it is visible, if the path of light is visible, then we say that it shows the Tyndall effect. So basically, the heterogeneous mixture will show Tyndall effect. Okay. Now, I have a question here. Whenever we have the homogeneous mixture getting formed or the heterogeneous mixture getting formed, is there any kind of chemical difference between them? Are they chemically different? Let us suppose. Is this difference based on some chemical property? Is this difference based on some kind of chemical property? What is this difference based on? What is all this difference based on? Okay, so very good. I got some answers. Okay, I'll just mute my mobile. I'll get the messages. Okay. Okay. Now the question is, I have asked you a question. I'll wait for your reply. Okay. What is the difference between the homogeneous mixture and heterogeneous mixture? Is there some kind of chemical difference? Is there some kind of physical difference? Okay. Okay. I have sent thumbs up to one who are sending me correct answer. Hmm? Okay, I'll just wait. Someone's typing the answer. I'll just wait for a while. Okay. Okay. Yes, homogeneous are the one which include the miscible substance, whereas heterogeneous are the one which include immiscible substances. Okay. I'm talking about the difference. What would be the difference between them? Chemical difference or physical difference? Now listen. They are different in terms of the physical properties. Okay, they are different in terms of the physical property, and basically, whether a given substance will form a homogeneous mixture or heterogeneous mixture will depend upon the size of the solute particle. Okay, a given mixture, whether it will form the homogeneous mixture or heterogeneous mixture, will depend upon the size of the solute particle. Right? If the particle size of the solute is very small, okay, if the particle size of the solute is very small, so small that it is practically invisible to the naked eyes, okay, and the division is almost to the molecular level, then we say that it will be forming the homogeneous mixture, okay. And if the particle size is quite large, okay, if the particle size is quite large, it is in the form of a cluster, an aggregate, okay, then we call it as the heterogeneous mixture. I hope you got the difference. Basically, this difference of homogeneous mixture and heterogeneous mixture is dependent upon the size of the solute particle. Okay, if the particle size is very small, okay, the division is almost to the atomic level or molecular level, then we call it as homogeneous mixture. Otherwise, we call it as the heterogeneous mixture. Right? Okay. Now, what do we call based on the size? Okay. Based on the size, we have the solution, the mixture are categorized as solution. Okay. Then we have got the colloidal solution and the suspension. Basically, these two are heterogeneous mixture based on size. Okay. And solution is your homogeneous mixture. Fine. Homogeneous mixture is solution. Heterogeneous mixture can be either colloidal or suspension, and this difference, whether a given mixture will be called solution, whether it will be called the colloidal solution or suspension, will depend upon the size of the solute particle. Okay. In this case, the particle size is less than 1 nanometer. In this case, the particle size is in between 1 micrometer to 1 nanometer. Okay, and in this case, the particle size is greater than 1 micrometer. Okay. In this case, the particle size is less than 1 nanometer. In this case, the particle size is in between, basically the suspension and solution. That is 1 micrometer to 1 nanometer. This is the particle size. Okay, and here the particle size is greater than 1 micrometer. Okay. This much done. Please note it down somewhere. Done. Now look, all the three states of matter can act as the solute or solvent. Okay, all the three states of matter can act as solute or solvent. Fine. Now let us suppose you have this is solute and this is solvent. Okay, and here you have got the state of matter. Now here, what will be the state of the solution? We'll discuss here. Now let us suppose first the solvent is gas. Okay, the solute is gas. If gas will combine with gas, the mixture is always solution. Okay, and it will be gaseous only. If you have, let's say, liquid mixed in gas, for example, your fog, mist, and so on. Okay, in that case, the solution will be gaseous. Okay, if you have solid in gas, if the solvent is gaseous, then the solution will always be gaseous. Okay, the solution has the same state of division as that of solvent. Okay, solution has the same state of division as that of solvent. Please note it down. Has the same state of division as that of solvent. Solution will always have the same state of division as that of solvent. Fine. Now, if gas is mixed in liquid, if gas is mixed in liquid, for example, carbon dioxide dissolved in water. Okay, you have the cold drinks, the carbonated drinks. In this case, what will be the state of the solution? It will be liquid state. Okay. If you have liquid mixed in liquid, then the solution will also be liquid. For example, the mixing of the syrup. Okay, in water, alcohol in water, okay, the solution is liquid here. Now which one is solid, which one is solvent will depend upon the amount of the substance which you are mixing. Then if solid is mixed in liquid, okay, then the solution form will be in liquid state depending upon the solvent. Okay, you'll see that the solvent solution here for the same state of aggregation or division. Fine. Now look. Then if gas is mixed in solid, okay, foam and all, then the solution form will be solid. Okay, your butter and all. Okay, sorry, I mean the foam. Okay, solid foam and all. If liquid is mixed in solid, okay, the solution form will be your solid only. And if solid is mixed with solid, okay, and the solution form is your solid. As in the case of alloys, in the case of alloys, okay, you have solid mixed with solid. Okay. So basically, when you mix the three states of matter, okay, with the other three states of matter, the different type of solution that you get is 9 different type of solutions are obtained. 9 different type of solutions are obtained. Okay. However, when you mix them, okay, to form the colloidal solution, then leaving gas in gas, which always form true solution, will have the same type of the colloidal system getting formed. So basically, all these three states of matter, when they are intermixed with one another, okay, in that case, we will get 8 different type of colloidal system getting formed. And when they form the solution, true solution, they will form 9 different type of solution. Okay. The reason being is gas and gas will always form true solution because they mix completely. Okay. They always mix completely. So leaving this one, you can have the 3 state of matter intermixing with one another. You will get 8 different type of colloidal system. Okay. The colloidal system are also same as the solution. This will be the colloidal system in that case. Fine. Okay. Now, what are the various methods by which we can separate the mixtures? Okay. What are the various ways by which you can separate the mixture? Now, let us suppose you have iron fillings mixed with sulfur powder. Okay. You have got iron filling mixed with sulfur powder. How will you mix these two components? They are mixed together, okay, and you have to separate them. What method will you take or carry out for their separation? Please send me reply quickly. What method do you think you will use so that you can separate these two components? I have a feeling, okay, it's powdered iron and sulfur powder. It is yellow color powder. Okay, so if you mix these two, what are the ways by which you can separate these two? Okay, fine. I got one answer. I'll be answering it later on. Okay. Okay. Fine. I got one more answer with, and it's same as the previous one. How will you separate these two components? Okay. The answers that two of you have sent me is that they can be separated by magnetic separation. They can be separated by magnetic separation. Okay. It is because iron gets attracted toward magnet, gets attracted toward magnet. Okay. Whereas sulfur is unaffected by magnet. Any other way? Some more way by which you can separate it. Hurry up. Okay. Using, very good. Using suitable solvent. That's the correct answer. Using suitable solvent. Okay, that's very good. That's correct answer. I think Harsimran has sent me that answer. That's very good. Using a suitable solvent in which either of this component may be soluble. Okay. For example, if I take carbon disulfide. Okay, this is the solvent, and I put these two in this solvent. This does not dissolve. Okay, whereas this one dissolves. Okay, so once the sulfur powder dissolves, we can make use of the filtration. Okay, to separate these two components. Fine. This is done. And remember that for separation, it might be that only one method may not be suitable to separate the two components completely. Okay? So you may require more than one method for their complete separation. Okay? So here, now let us suppose you have a mixture of oil in water. Okay? You've got oil in water. How will you separate these two components? Oil in water, how will you separate these two components? Aryan, Okay. By sublimation, I did not quite get it. What is this exactly? Why sublimation? Huh? No. Okay. How will you separate these two? Oil and water. How would you separate these two? Oil and water. Okay. Oil do not mix with water. Okay. Oil do not mix with water. Okay. So you can make use of the separating funnel. You can make use of the separating funnel. Okay. It is because they will form two layers. If you allow it to stand for some time, okay, the oil and water they will form two layers, and you can easily allow one of the liquid to escape from the bottom. Okay, and once the first liquid has been removed from here, you can close the stopcock. Okay, the other liquid will remain inside this one. Okay, this is similar to decantation. This is similar to decantation, in which if you have to separate muddy water, what do? You allow it to stand for some time. Okay, you allow it to stand for some time, or maybe you can have some alum added to it. Okay, in that case, you will be calling it as loading. Okay, you give a substance to which the mud can get attached to. Okay, so mud will attach to alum, as a result of which the mud gets heavier, they start settling down at the bottom. Okay, and that is to quicken the process of decantation. That is called loading. Okay, and it is done by adding alum. Fine. The other is filtration, of course. Okay, but other than filtration, you can make use of decantation method. Okay, and this is similar to this one, decantation. When you allow those to mixture, and this is when they do not form the homogeneous mixture. Okay, and they can separate into two layers or different layers. Then we can make use of this method, decantation. Okay, you allow the muddy water to stand for some time, then what will happen? The muddy water will start settling down at the bottom, and this is how the separation can be done. Fine? Okay, sure. That's all for today. I'll just leave 2-3 minutes for your doubts. If you have any doubt, you can ask me a doubt. You can send me your questions. Okay, please check. Separating funnel. Yes, that's correct. Separating funnel. That was correct. Okay. At time the messages I get late. Okay, separating funnel. That's correct. That was correct answer. Someone had sent me sublimation. I did not quite get it. For which you are saying sublimation? Sublimation is when you have any substance which can sublime, which can directly convert from gaseous to vapor form. Okay, and I don't think oil. I doubt I have asked about oil and these are substance only. These are not subliminal substance. Okay, so no doubt. Any questions? Others also, if you have any query, any doubt, any question, you can send me your questions. Chalo, all done? Chalo, fine. Someone is typing, I'll just wait. Okay, fine, no doubt. Chalo, fine. We'll continue with the lesson. Okay, that's the same lesson. On next. Chalo, till then you can revise, okay? And go through the chapter. If you have any query regarding the chapter, you can ask me. Thank you. Have a nice day.